Imagine, if you will, a cat that is literally the size of a polar bear. It's got the thick, heavily muscled arms of a silverback gorilla. And here's the crazy part two 8-inch scalpel blades just protruding completely out of its mouth.
Yeah, I mean, it's a terrifying visual.
Right. And now imagine its jaw dropping open to this impossible, like, 120-degree angle right before it sinks those blades into the throat of a struggling mammoth.
It's pure nightmare fuel.
Okay.
But, what makes it so fascinating from a scientific standpoint is that a creature like this technically defies a fundamental rule of biology.
Right, the energy transfer thing. Because if you think about energy in an ecosystem, there's this almost unbreakable ceiling on the size of carnivores. I mean, herbivores get their energy straight from plants. They're the primary consumer.
Exactly. They get the raw energy.
Yeah, but predators, they only ever absorb about 10% of the energy that the herbivore originally took in. So because of that massive drop-off, predators are almost always way smaller than their prey. A lion is smaller than a buffalo. A wolf is smaller than an elk.
Generally speaking, yes. But every once in a while, evolution it throws that mathematical constraint right out the window. It engineers this biological anomaly, an assassin that's specifically designed not just to survive alongside giants, but to actively hunt them.
Which perfectly brings us to our mission for today. We're doing a deep dive into this phenomenal breakdown from Apex Truth. And we're basically stripping away all the pop culture myths to look at the biology, the 20 million year rise, and the ultimately tragic fall of the Ice Age's ultimate apex predator.
A Smilodon.
Exactly. Better known to you and me as the saber-toothed cat.
And to really appreciate what this animal was, we have to start by completely discarding that cartoon image of a big fluffy tiger just, wandering around the snow. The reality of the Smilodon was brutal. It was highly specialized and honestly a marvel of biomechanical engineering.
But, okay, before we get into the mechanics of how it hunted, we have to talk about how we hunted for its identity. Because, and I love this, when scientists first dug this thing up, 160 years ago in Brazil, they got it hilariously wrong.
Oh, completely wrong.
They found these isolated cheek teeth, looked at the shearing structure, and just confidently announced to the world that they had discovered a massive prehistoric hyena. I mean, they literally named it Hyena Nioga.
Which, seems absurd in hindsight, given that felines and hyenas are on entirely different branches of the carnivore family tree.
It's like finding a Great Dane's jawbone and being like, ah, yes, a highly muscular raccoon.
Right. But the mistake actually highlights this brilliant biological principle called convergent evolution.
Oh, this is where unrelated animals end up looking identical because they have to solve the same problem, right? Like how a shark and a dolphin have that exact same torpedo shape and the dorsal fin.
Even though one's a fish and one's a mammal.
Yeah, exactly. It's just because they both have to move efficiently through water.
That is the perfect analogy. So in this case, the environmental water was the need to shear through thick hide and dense muscle. Evolution arrived at the exact same tooth shape for both the prehistoric feline and the hyena, because it's just the most mathematically efficient tool for slicing meat.
Okay, that makes sense. But the hyena illusion didn't last long, did it?
No. A few years later, paleontologists started pulling up more fossils. It wasn't just cheap teeth anymore. They were finding these giant canines, massive skull fragments, and these incredibly robust foot bones.
And that's when they realized, okay, this is undeniably a felid.
Exactly. But it was a felid built unlike anything walking the earth today. So they scrapped the hyena label, reclassified it under a distinct genus, and gave it a name that honestly sounds like a mythological deity. Smilodon populator.
Which is the most badass name in science. Smilodon, meaning knife tooth, and populator. The source translated it from the original Latin to the destroyer, or he who brings devastation.
It certainly carries weight. But it also requires us to clarify the family tree a bit, because the common moniker, saber-toothed tiger, is completely inaccurate.
Right, they aren't tigers at all.
Not even close. They belong to an extinct subfamily called Machaerodontinae, which translates to dirk-toothed cats. Their lineage split off from the ancestors of modern cats millions of years ago.
Wow. Okay, so if you're looking at a modern tiger or a lion at the zoo, you are not looking at a close cousin of the Smilodon.
No, you're really not. And the destroyer didn't just appear overnight either. This was a lineage that basically leveled up sequentially over millions of years.
Yeah, the timeline starts about 2.5 million years ago in North America with Smilodon gracilis.
Right. That was the oldest and the smallest of the three recognized species. Though, smallest is highly relative here.
Yeah, because it was roughly the mass of a modern jaguar, which is what, the third largest cat on Earth today? Still a massive animal.
Exactly. But then, a million years later, the environment pushes them to evolve again, and we get Smilodon fatalis. Now, this version is heavily documented in North America.
And this is where they start getting really scary.
Oh, absolutely.
Yeah.
It had the overall frame and height of an African lion,
Sure.
but it was so densely packed with muscle that it weighed around 280 kilos.
That's about 620 pounds.
Right. That puts it at the absolute maximum weight of a large modern Siberian tiger, but compressed into a lion's more compact dimensions. And that density of muscle mass is critical to understand because it dictated how the animal moved and hunted.
And if that wasn't terrifying enough, jump forward 600,000 years after Fatalis. The lineage spreads down into South America and produces the absolute giant Smilodon populator.
Weighing up to 470 kilos.
Over 1,000 pounds.
To give you, a visceral sense of scale here, 1,000 pounds is the mass of a medium-sized polar bear. Just imagine looking into the eyes of a cat that possesses the sheer gravitational presence of a polar bear. I physically cannot. And here's a detail from the deep dive that really jumped out to me. They didn't have high sexual dimorphism.
No, they did.
Which means, well, in modern lions, the males are massive and have these big manes, while the females are significantly smaller. But male and female Smilodons were roughly the exact same size.
Exactly. Virtually every adult in the ecosystem was a 1,000-pound apex threat. It drastically alters how we view their population dynamics.
But sheer mass isn't enough to take down Ice Age megafauna, right?
Yeah.
I mean, a multi-ton ground sloth or a giant bison doesn't really care if you weigh 1,000 pounds if you can't control it.
That's right. And that's why the Smilodon's anatomy was engineered for leverage. Let's talk about that engineering, starting with the hind legs. Their heel bones were unusually long for a cat.
Yeah, based on the bone density and the physics of leverage, biomechanical models suggest they had this insane jumping power. We're talking speculative vertical leap of over 15 feet.
It is staggering. That vertical allows a massive animal to instantly close the distance and clear the height of towering prey, like a mammoth or a mastodon. Just picture a 1,000-pound cat launching itself 15 feet in the air to land squarely on your back. And once it landed, it utilized forelimbs that were 20% thicker than what biomechanics would even predict for a cat of its size.
And that 20% deviation is vital. It means the forelimbs weren't just meant for walking or running, they were specialized tools for immense gripping power.
And attached to those forearms were fully retractable claws that were proportionally gigantic, like twice the size of a Siberian tiger's claws, longer than the claws of a Kodiak brown bear. And a Kodiak bear can weigh twice as much as a Smilodon.
Those claws are the key to their entire hunting strategy. They function basically as grappling hooks.
If you follow combat sports, this makes perfect sense. The Smilodon wasn't a boxer relying on striking power. It was an elite MMA wrestler.
That's a great way to look at it.
Yeah. It wasn't built for a prolonged stand-up fight where it trades blows with a bison. It was built specifically to tackle its prey, use those massive forearms and claws to take it to the ground, and just pin it to the mat so it couldn't thrash around.
And pinning the prey was absolutely mandatory because the Smilodon's finishing move, the iconic saber teeth, well, it came with a massive biological vulnerability.
8-inch daggers,
Yes.
just hanging completely out of its mouth.
The longest canines of any known feline, and their geometry is brilliant. The tops had a very sharp point, but the sides were entirely smooth and incredibly narrow, much like a flattened blade.
So they slice through thick hide with basically zero drag. But this brings up the most counterintuitive fact about this whole animal. If you're listening to this, you might be wondering the exact same thing I was when I first read the source material. How can the absolute king of the Ice Age have a bite force measured at just 1,000 newtons?
It is shockingly low.
It's 4 times weaker than a modern lion's bite, and it makes no sense on the surface. Why build a polar bear-sized cat and give it a weak jaw?
It all comes down to the material limitations of teeth. Those 8-inch canines were long, slender, and surprisingly fragile.
Wait, fragile?
Yes. If a Smilodon bit down with the bone-crushing force of a lion, and those long teeth hit a struggling bison's femur or a thick rib bone, the sheer torque would snap the teeth right off. And a saber-toothed cat with broken sabers is, well, it's a dead cat.
Ah, okay, so this is where the pieces fit together. If the bite is weak and the teeth are incredibly fragile, they cannot be biting through bone. They have to be targeting soft tissue exclusively.
That is the logical conclusion. You have to think of those teeth not as a sledgehammer, but as a surgeon's scalpel. A scalpel doesn't require massive brute force to be deadly, right? It just requires pristine placement.
Which is exactly why the wrestling forelimbs were so important. You can't perform delicate surgery on a patient that is thrashing around. You have to pin them perfectly still.
Precisely. So once the giant prey was completely immobilized by those massive arms, the Smilodon deployed its jaw. And to clear those massive teeth out of the way, the jaw hinge itself had to be evolutionarily modified.
Yeah, it could open to 120 degrees. I actually tried opening my mouth as wide as I could while reading this, and humans top out around maybe 50 or 60 degrees. The Smilodon essentially had to unhinge its lower jaw until it was completely flat against its neck.
And to achieve that, they actually had to sacrifice the large coronoid process, which is the part of the jawbone where the powerful chewing muscles attach.
Oh, so smaller muscle attachments meant a wider opening, but it resulted in that weaker bite force we just discussed.
Exactly. It's a total anatomical trade-off. Once the jaw was wide open, the Smilodon didn't bite and chew. It used rapid downward thrusts of its powerful neck muscles, driving those scalpels deep into the softest parts of the prey, usually the belly or the throat.
Bypassing the bones entirely.
Yes, it instantly severed major arteries and the windpipe, causing catastrophic blood loss and suffocation in just a matter of seconds.
It is precision assassination. But here's the thing. The level of precision required by those teeth meant they couldn't afford a chaotic struggle. They needed absolute control over the situation, and an immobilized target stuck in the mud. That looked like the perfect opportunity.
Which perfectly explains the La Brea tar pits in California.
Yes. The tar pits acted as massive predator tracks. Over 160,000 Smilodon fossils have been excavated from La Brea.
It's an incredible number. And 90% of all the fossils found in those pits are predators.
It's a horrifyingly brilliant trap. A single herbivore wanders into the tar, gets stuck, and starts making distress calls. Every carnivore within hearing distance thinks they just won the lottery. They rush in for a free, immobilized meal, and they sink too.
And the sheer volume of Smilodons converging on these sites has sparked one of the biggest debates in paleontology. Were they solitary hunters, or did they live in complex social packs?
And the argument for them being pack animals comes down to something we might call tar pit healthcare, right?
Yes. Among the thousands of skeletons pulled from the tar, paleontologists consistently find individuals that suffered from severe, debilitating trauma long before they died.
Like what kind of trauma?
We see evidence of massive broken bones that eventually healed, or crippling hip dysplasia that was present from a very young age.
But if you're an ambush predator that relies on a 15-foot vertical leap and immense grappling strength, a bad hip is a death sentence. A solitary cat with a broken leg just starves to death in the wild.
Exactly. But these fossils show individuals surviving well into late adulthood. The implication is staggering. Other cats must have been bringing them food and protecting them.
It's a deeply compelling argument for a complex, empathetic social structure, similar to modern lion prides. But in the spirit of scientific rigor, we have to examine the counter perspective, because not everyone buys the pack theory, do they?
No, they don't. Many paleontologists argue the exact opposite. They point out that when we find Smilodon skeletons in open environments, so outside of these unique predator traps, they're almost always isolated finds.
So if we look at the isolated skeletons, the tar pit phenomenon might just be an illusion.
Right. It doesn't necessarily mean they were a coordinated pack.
Yeah.
It could just mean a dozen greedy, highly aggressive, solitary cats all heard a dying mammoth and independently decided to jump into the same tar pit.
So it's a mystery that remains unresolved. Did they hunt in coordinated mafias protecting their wounded? Or were they just opportunistic loners drawn by the siren song of a dying herbivore?
The evidence pulls fiercely in both directions. It leaves us to wonder just how sophisticated their social lives really were.
Well, whether they rolled in an organized syndicate or hunted strictly alone, they lived in a brutally competitive neighborhood. We're talking Ice Age Fight Club here.
Oh, the competitors were formidable. You had dire wolves, and yes, they were real, not just a fantasy invention.
Right.
You had American lions, which were significantly larger than the lions we know today.
Yeah.
And you had the short-faced bear.
Okay, I have to pause on the short-faced bear, because just saying a bear sounds like, a regular bear. But this thing was built differently. If you stood next to it on its hind legs, you would literally be looking up into a second-story window. It was monstrous.
It was a chaotic ecosystem. But we actually know quite a bit about how these predators interacted, and we know this by separating the chemical evidence from the physical evidence.
Break that down for us. How does that work?
The first, we use isotopic analysis. By examining the ratios of carbon and nitrogen isotopes locked inside the bone collagen of these fossils, Scientists can determine exactly what an animal was digesting over its lifetime.
Oh, wow.
And that chemical signature tells us that smilodons, dire wolves, and American lions were all hunting the exact same prey species.
So they are competing for the exact same menu.
Yes. But then we look at the physical tar pit evidence, the proximity of fossils, the bite marks on bones, to see how they interacted over that menu. And the physical evidence suggests smilodons were massive bullies. Yeah, they routinely forced dire wolves to yield their kills. The smilodon would just take over the carcass and devour it.
The 1,000-pound cat just walks up and takes your lunch. I love it. How did they handle the American lion, though?
The American lion was slightly taller and longer, so they generally respected each other's space. But if forced into a conflict over a carcass, the physical mass of the smilodon made it a relatively even fight.
And the second-story window bear.
The short-faced bear was largely solitary and highly omnivorous. Despite its immense size, it usually wasn't worth the risk of tangling with 8-inch sabers. If a bear saw a smilodon on a kill, it would typically just keep walking.
Speaking of being on a kill, I have to highlight this because for all the brilliant engineering of the smilodon, evolution left them with a wildly awkward design flaw when it came time to actually eat.
Yes. The teeth were in the way.
Exactly. If you have 2 giant daggers blocking the entire front of your mouth, you can't bite a piece of meat off a carcass. You physically can't get to it.
So they had to rely on a different set of teeth called carnassials, which were located on the sides of their jaws.
Which means this terrifying polar bear-sized assassin, after executing a flawless precision kill, had to tilt its head awkwardly sideways and basically chew out of the corner of its mouth to slice its meat.
Just crank its neck at a 90-degree angle to eat its dinner.
Is a wonderfully bizarre workaround.
It might have been awkward, but it was undoubtedly effective. I mean, the smilodon lineage was incredibly successful. They established a vast territory stretching all the way from modern-day Canada down to Patagonia in South America.
And they thrived right alongside us. Homo sapiens and smilodons crossed paths roughly 25,000 years ago. It is wild to think about this petroglyph discovered recently that actually shows human figures watching a smilodon from afar.
It must have been an unbelievably tense coexistence. We were hunting the exact same megafauna, and given the opportunity, we undoubtedly hunted each other.
But despite their perfect weapons, their sheer mass, and their millions of years of dominance across 2 continents, the destroyer didn't survive to the modern era. Roughly 10,000 years ago, right around the time humanity was beginning to domesticate crops and invent agriculture, the smilodon vanished completely from the fossil record.
It's the extinction of the giant slayer.
Why did they disappear? Was it our fault? Did we hunt them to extinction?
Human impact is definitely a factor in the debate. As early humans mastered the use of fire, we fundamentally altered the landscapes. We burned away the dense forests and brush that the smilodon relied on to ambush its prey.
Oh, that makes sense.
Furthermore, we actively competed for the same food sources. But the larger issue was the food source itself, right? The Quaternary extinction event. The end of the Pleistocene epoch was marked by rapid, violent climate shifts. The planet warmed, glaciers retreated, and the ecosystems transformed. This environmental upheaval triggered a global die-off of megafauna.
So the giant ground sloths, the mammoths, the enormous bison, the very giants the smilodon was engineered to kill, they all began to starve and die out.
And this is where the tragedy of evolutionary hyper-specialization really reveals itself. The smilodon was engineered to absolute perfection.
It had the 15-foot leap, the grappling hook claws, the 120-degree jaw, and the scalpel teeth, all designed to wrestle and dispatch slow, heavily armored giants. But when the climate shifted and those giants disappeared, what was left?
Smaller, faster, highly agile prey, deer, antelope.
Animals that a 1,000-pound, densely muscled wrestler simply cannot catch.
Biologists refer to this as the curse of its own blessing. The smilodon was the ultimate giant slayer in a world that suddenly had no giants left.
Wow.
Its jaw couldn't crush the bones of smaller prey without breaking its sabers, and its massive frame required too much energy to chase down fleet-footed deer. It was biologically incapable of adapting, and so it starved.
It totally makes you think of a technology company that perfects a singular, incredible product. Like you build the absolute greatest, most complex VCR the world has ever seen. It is a masterpiece of engineering.
But overnight, the entire global market switches to streaming video.
Exactly. But it doesn't matter how perfect your VCR is, the environment changed, and your perfection is instantly obsolete. And just like that, a 20-million-year reign of the saber-toothed family comes to a quiet, starving end.
It is a profound lesson in the mechanics of survival. In biology, broad adaptability is almost always more valuable in the long run than extreme perfection.
That is a very sobering thought, and it beautifully wraps up our mission for today. Thank you for joining us on this deep dive into the biology and legacy of the Smilodon. It remains a breathtaking, terrifying, and ultimately tragic example of extreme evolutionary specialization.
And as we connect this ancient history to the bigger picture, it leaves you with an important question to consider.
What's that?
Well, the Smilodon was flawlessly optimized for its specific era, which is exactly what doomed it when the environment suddenly shifted. So as you look around at our modern world today, what current apex systems, whether that is a modern animal species, our own human technologies, our global supply chains, or our highly tuned economic models, what systems are so rigidly specialized for today that they might face their own immediate extinction if the landscape suddenly changes tomorrow?